Hello, and welcome to the Grouping and Mapping course, Chapter 3, Lesson 5. In this video, we're going to take the data that we extracted previously, and we're going to present it in the reports for our engineers. As a reminder, the first of our two engineers is Paul, the procurement manager. His job is to create a report of all the doors and windows that need to be sourced for this project. His final report will look something like this. It's a bill of materials of all the installations grouped together by their size and perhaps other factors, with a total count in the rightmost column. This provides an easy and straightforward way for Paul to know how many of each item needs to be procured and delivered on time for construction. Next is our information manager, Irene. She needs to understand the environmental impact of the project. To do this, she'll apply a heat map to the project's model. The final report will look something like this. We can see the heat map applied in the viewer itself, with a gradient at the bottom replacing our table. We can see the high and low bands of our gradient to understand the scale we're working with here. Irene will use this to intuitively understand where her attention would produce the best results when reducing the environmental impact. To create these reports, we'll follow the same workflow that we used in the previous videos. We use the iModel OData client to interact with the OData APIs and extract the data. In the previous video, we just dumped that all into the raw OData widget to understand what was being returned from our client. We're going to follow the same base structure, but we'll pre-process the data first and replace the user interface, so that this would give us the ability to use the procurement table for Paul and have our environmental impact widget for Irene. Now, let's jump into the code and see how it's done. This application was built on the Viewer app. We've installed packages, written code to add the grouping and mapping widget and the raw OData widgets. In this video, the code for the engineer's widgets have been added. Looking at the Explorer, we can see the environmental impact and procurement directories have been added. They both contain a widget and provider files, as well as an additional React component specialized for the report. If we run the application, it would look like this. A link to a repository for the application we're using right now can be found in the description below. Now let's start looking into the widgets themselves. We'll start in the procurement widget for Paul. As a reminder, his report is a bill of materials, with all similar elements grouped together. His widget follows a very similar workflow to that of the raw OData widget. Looking at the React, we can see the familiar component, the data selection field set. This lets the user select the grouping to be applied to this report. The onChange configuration callback still triggers our data to be loaded into the widget, using our model OData client with the get OData report entities method. The load metadata method is requesting the quantity types of the properties. Moving back to the React, the component at the bottom is now the procurement data table. This is where the pre-processing of the data will be done before it's displayed in the data table. So let's move in there and see what's going on. Before we get too far into this component, I want to point out the arguments to the method as well as a state variable. Looking at the arguments, we see table data, table metadata, and quantity metadata. Table data is the raw data requested using the OData API. Table metadata is the column headers. This is the information that comes from the group itself. Quantity metadata is that metadata from the properties, our quantity types. In looking at this state, we see the procurement data. This procurement data is going to be the table data restructured as a bill of materials. This is what's going to be presented in the data table. If we scroll down to look at the table component, we can see this. Now before we move into the use effect that is populating our procurement data, we're going to look at our columns. This looks very similar to the raw OData widget. It's mapping the ID, header, and accessors based on the name, and header is based on the name plus the units. But if we look at the bottom, we can see an extra row being added. This one is called count. This column is where the total number of each installation is going to be added. Now let's scroll down and look at the use effect that is creating that procurement data, counting each of those installations. The first thing we see at the top of the use effect is generate property hash and deconstruct property hash. These property hashes inform the table if the elements described in the table data rows are the same. It's done by taking the elements row, hashing the properties together, then creating a map with those hashes as the keys. The count is found by using the length of the elements attached to the map's keys. By deconstructing those keys, the hashes, we have the unique elements or installations. We complete the final step by appending the count data for the count column we defined earlier. The procurement data is now ready to be presented in the bill of materials. Now let's move over and look at Irene's environmental impact widget. Remember, the goal here is to apply a heat map to the elements within the group. Looking at the React at the bottom, we see the same layout. We have our data selection field set, but this time it allows properties to be set. Then we have the component at the bottom called gradient legend. All this is doing is displaying the legend that we create. Where that legend is being created is here in this widget. Looking in the onChange configuration callback, as we've seen in our other widgets, our group data is being loaded in here, as well as our group metadata. We filter out any undefined or null values. If you remember, Irene's report is about giving an intuitive understanding about the data, not having an exact understanding of it. So having null and undefined values here is expected. Now we see the next function is generate heat map. This is where the bulk of the pre-processing for this report happens. This method starts by making a pass over the data, finding the min and maximum values. The second pass is to assign the elements a color. This color is decided by taking the driving property value, in this case volume, and interpolating that value between the min and the max values we decided by our first pass. Once every element has been assigned a color, we then use the iTwin.js front-end feature emphasize elements to colorize all the elements of our grouping. And that colorization completes our report. And with that completes our tour of the application. We went over how to present the data in Paul's procurement report, as well as Irene's environmental impact report. And now that we've finished our presentation step, we now have completed all the steps in order to create our engineer's reports. And this also means that we've finished the tour of the application, which was the goal for this chapter. I'll see you next time.